ColorLogic and CrossXColor webinar. This time it's about DeviceLink profile creation. And the topics we are covering today will be about the advantages of the CoPra module, because we are looking at the CoPra, the color profiling application from ColorLogic, to create those DeviceLink profiles and later on to apply them with CoPra. First of all, we will start to explain a little bit what a DeviceLink profile does and which challenges it solves that you normally have with ICC color conversions. And then we are going on to create typical DeviceLink profiles with CoPra, especially CMYK-to-CMYK and RGB-to-CMYK. You will see that the profile creation process is quite easily done with CoPra, but you always want to know how good your profiles are, and therefore the checking and, of course, the applying of those DeviceLink profiles is a very important part, which I will cover during the presentation as well. And I will show you what we call the preview profiles and how to use them for the DeviceLink conversion in CoPra. This is the second of a series of webinars that we are offering, and in the future we have a few more webinars in our planning. So the next one will be on August 29th, where we'll be applying all those DeviceLink profiles that we are creating today on PDF files, so that we do PDF color management. And we are setting up typical workflows with our color server Zebra. Future planned webinars will be in the fall of this year, especially workflow configuration and case studies with Zebras. For example, gradation corrections on the fly, DeviceLink creation on the fly with our SmartLink module. And we'll have a specific topic for those that are interested in spot color and multicolor workflows with CoPra in Zebra. Before we start and look into the application CoPra, this is our primary goal of this today webinar, color profiling application. I want to give you a short overview about this very mighty functionality, because we've looked at it at the first class ICC output profile generation that it's able to create in the last seminar. This one is about DeviceLink technology, so we will look at the DeviceLink module and as well at the SafeInk module that is able to create the SafeInk and tag reduction DeviceLink profiles. There's another module, which is the editing module, that is able to save any type of color conversion in a DeviceLink, including as well abstract profiles, but this will not be covered today. That will be covered in a future seminar. Advantages we have when we work with CoPra. So first of all, CoPra is the first-class professional application designed for the high-end market. And when we're talking about press and printing and pre-press, this is a high-end market where the quality is needed. It offers the maximum control for the DeviceLink profile creation. And despite this maximum control, it's still an easy-to-use application. So you will see that. We've seen this the last time with the high-end printer profile quality that we can create with CoPra. And with all these functionalities and ease of use, it is the best profiling solution for printing companies, pre-press managers, and press operators. It includes all profiling features for packaging and hi-fi printing companies as well. So for those that want to create multicolor separations and such, we have solutions as well inside CoPra. And CoPra is a complete suite of application. It includes as well the color end application we looked at the last time for measurement data optimization. We'll have the DocBeast Profile Manager tool and the measuring tool, which comes from the UGRA, which is called UPPCT, which is as well included inside CoPra. So let's start with why we need DeviceLink profiles. And the typical problem that you'll have with CMYK-to-CMYK conversion is that you'll start with a 4-channel data set. So you have 4 channels, CMYK, and whenever you're doing an ICC conversion, you will always convert via the LIB color space. So basically, you're going from a CMYK to LIB to the next CMYK, to your target CMYK. And the result is basically that you lose all the black composition and pure color information of your source images or vector files. And that's a big problem. For example, a typical problem is that the overprint information is lost. If you look on the right-hand side, you will see 3 circles having cyan, magenta, yellow, overprinting each other. The area where they are overprinting, you see the resulting color, for example, red, green, and blue. Whenever you're doing a normal ICC conversion, typically the CMYK-to-CMYK conversion will add a fraction of contaminating color. So you don't have a pure cyan or pure magenta or pure yellow anymore, but a little bit of percentage of the other colors will join in. And during that, the overprint gets lost. And that's a very big problem, which is easy to spot in a PDF document if there's a wrong color management applied. The other thing, which is very dangerous, is that the black composition is removed. This can be shown in the graph below, where you see this CMYK blends of colors. So the middle, that's the original one, so that's the CMYK, and below you always see the black channel of that CMYK image on top. If you look on the left-hand side on that image, you'll see how the conversion is done after CMYK-to-CMYK conversion with normal ICC profiles. You see the black composition is completely changed, and you see as well some artifacts in the CMYK blends, which is not nice. On the right-hand side, you'll see that the DeviceLink conversion, which has been applied on this conversion, only affects colors in a very subtle way. Only certain areas will be touched, and you get much cleaner and less artifacts during the conversion. And other things that can happen or will happen with normal CMYK-to-CMYK is that if you have a black 100% text and you do a conversion of vector graphics and text elements, this text renders into 4 colors, which will become muddy or distorted when produced later on. The same happens with gray areas that are transformed to 4 colors at the end. The same happens with smooth blends and vector graphics that get muddy or are not smooth after the conversion. The solution to all those problems is using high-quality DeviceLink profiles to convert the CMYK data, which means images and vector graphics, to customize the print and production process. If you think on the typical applications for DeviceLink profiles, where do you use those DeviceLink profiles? These are a lot of examples are here, but the very typical one is the repurposing of CMYK jobs. Mostly these are PDF files, so assume you have a PDF document which is produced for a Greco color space, but your client demands that you should print it on a coated web paper, grade 5, so swap 5 process. So you need to do a CMYK-to-CMYK conversion. That's a very classical use case for DeviceLink profiles, because CMYK-to-CMYK should only be done with DeviceLinks. Otherwise, you'll have that issues that I mentioned before in my slide. Another very typical situation is that a file, a PDF document delivered to you has too much ink. Yeah, so there might be 400% of CMYK in that document, and on press you probably can only reach 300%, depending on the paper type and the printing process you want to print on. So you want to control the total area coverage or total ink amount on press. A typical application is to use tag reduction settings with DeviceLink profiles. For printers, especially the stabilizing of the printing process is important. So you want to use a very moderate reseparating, to use more K and less CMY to stabilize the printing process. Save on ink, especially in this climate and industry we are in, where people want to save money. You can save a lot of money by using Save Ink DeviceLink profiles and saving the inks during the process, but of course by keeping the same color quality. Another use case is the conversion to multicolor printing. If you think on CMYK to multicolor, it has basically the same challenges that you have in CMYK to CMYK conversions, and you can avoid those problems and get better results using DeviceLink profiles for CMYK to multicolor. And the next thing which we will start as well to look at into more deep detail is a superior RGB to CMYK separation, where you get cleaner primary and secondary colors and a very good saturation when compared with normal ICC conversion. And this is where I would like to start the technical part of this presentation. So what we would like to do is to start by RGB to CMYK. And during the last presentation, I showed you already an example how an RGB to CMYK separation, when we want to convert from Adobe RGB, for example, to swap coated 5 paper, will look like. So this is my original Adobe RGB image that I have opened here in Photoshop. That's basically our test image that we supply with CoPra. If I'm switching to the CMYK conversion, you'll see this is the conversion using a normal ICC conversion created with CoPra. We've done this the last time and applied that. And if I'm zooming in this area here where we see the pure red, green, and blues and cyan, magenta, yellow colors, this is the conversion to CMYK. And if I'm switching to a DeviceLink to do this conversion, you'll see that you get much cleaner colors. So you get a real cyan, if you like. You get a more saturated magenta. You get much higher saturated reds. If I'm switching now between the normal ICC conversion and the DeviceLink conversion, you'll see much cleaner colors here. That's one of the beauties of the DeviceLink, where you can target the conversion to give you much higher saturation, much cleaner colors. I would like to show you how to create those DeviceLink profiles in CoPra. So we are using CoPra now, and we want to create a DeviceLink profile, so we are switching to the DeviceLink profiling module here. So first of all, I would like to show you a very nice feature inside CoPra. The DeviceLink profile I've created already. So whenever you receive a DeviceLink profile created from CoPra, and you want to see how your client or your partner or your consultant has created this profile, you can simply take that profile, drag and drop it here to the source profile setting and to the target profile setting, and as well to the settings, which means that all those settings used in the DeviceLink, being the source profile, the target profile, and the settings itself, are now extracted from the profile and can be used and seen so that you have a good overview of how this profile was created. It's a very nice functionality, very helpful for testing, for evaluating, for using a profile and changing a setting and don't change the other settings. So that's very, very helpful. For a DeviceLink profile, that's a specific class of ICC profiles. We always need a source profile and a target profile. And as we are going from Adobe RGB to swap, that's the two profiles I've combined here into one profile. There's this correction profile, which you typically set to none for normal DeviceLinks. So we go to customize to see a little bit of how those settings are working. And I'll start with the black generation. And that's basically very, very similar to what we've seen the last webinar, where we created CMYK printer profiles, because these are the settings that you want to use to create this swap-coded profile, basically. So the DeviceLink profile incorporates the separation as well as with a normal ICC profile. So that's nothing new. The new and important part are the rendering and the exceptions. We'll look into the rendering into a CMYK-to-CMYK example, but this time we want to look into the exceptions to start from scratch, basically. And we are showing here in this graph an RGB base image. And if, for example, you want that your yellows and cyans and magentas are really pure, you simply click the primary option here. And it applies the color management for pure cyan, magenta, yellow gradients, and the software shows you which of those colors are affected from this option that you're choosing. The same happens for secondaries, meaning reds, greens, and blue combinations. So those colors are as well shown here in this red and marking which colors are affected. You could as well make sure that the gray is only using black after the conversion. Probably not a good choice if you are converting photos, images to CMYK. You don't want that they are only using black. But sometimes this is a very important functionality. For example, if you think on screenshots that you want to print only in black, then you could use that option. That could be a nice functionality. Or this one, to have preserve 100% black. That means only this black patch here, meaning a pure RGB 000, is only rendered using 100% black in CMYK. You can target the way how the conversion shall be doing. And that's what basically I have used in my setting, or going back to my profile setting I've selected, you'll see that I've as well used the max RGB setting, and that makes sure that I get this maximum saturation for red, green, and blues that I had in my profile. Whenever you start using to create a DeviceLink profile RGB to CMYK, it's always a good idea to start with the automatic mode. So I'll switch this off, because typically you are not sure which kind of settings you would want to have, and the automatic mode calculates the best settings for you depending on the source and target profiles. So if you click on automatic, you'll see if I switch this to custom, so it would say that secondary options is a very good choice, so you should use that, and it would suggest to just use the yellow part. And the reason why it would do that, I can show you again inside Photoshop, because when you look at this gradient from the beginning that we had, if we have the conversion like this, so that's how the normal ICC conversion is doing, and if I do the DeviceLink conversion, I have these very nice colors, so that might be very good, but the color is quite, for example, for the cyan here, is quite different to the ICC conversion. And if you want to have it as close as possible to the ICC conversion, to the normal ICC conversion to this color, then you would not have this cyan and magenta checked. And therefore, if I'm looking here, I've created a DeviceLink with exactly the settings that the automatic option was choosing, and that's this setting. So still an improvement over the normal ICC conversion. But with my personal setting, where I defined myself, I want this maximum red, for example. Look on this area here, where this maximum red comes in. I get a much higher saturated red on my output. But this is not an automatic calculation. This is my personal feeling that this image would be better if I use this option. So you'll have mathematical calculations how you want to do the conversion in an optimal way. Therefore, you use the automatic mode. And for the custom mode, you always have the option to say, okay, I want to have more. I want to have as well for cyan, for magenta, and I want to have the max RGB. Whenever you have defined your exceptions, you simply use the next button, again to the next button, and then you simply name the profile you want to have, and define the profile format, either version 2 or 4. I always recommend version 2. The large size is a good compromise in terms of quality and the size of the profile. And you have a very nice feature as well here, which is the preview profile. And we will be using that preview profile in the example later on. And as well, you can create a profile report, which gives you all the information you want to know about that profile. So that's a very nice functionality inside CoPra, that it will create this report. So if you click on Save, it will create those profiles. I'm switching to the original one. So that's my original RGB image. And I would like to show you the use of the preview profiles that CoPra creates. When you have your Adobe RGB image here, you want to see how the conversion will be with that DeviceLink profile. But there's no option inside Photoshop that would allow you to use a preview DeviceLink profile for the soft proofing. And therefore, we use the preview profile, which is basically a trick that we are doing that converts the DeviceLink profile into an RGB profile for the previewing that can be used then inside Photoshop. And it's very simple to use. You simply go to View, Proof Setup, to the Custom, and then you're looking for the device to simulate, which will be our Adobe RGB to swap preview profile. We will name the profile the same way as the DeviceLink, and we add the preview name here. So you simply select that. You click the Preserve RGB numbers here, and here you go. And that gives you basically the same conversion as you would get with the DeviceLink when you apply that. So I click this here, and I switch back to my DeviceLink here. And if I switch between both of them, you'll see that the colors don't change. So this one is already, that's my RGB with the preview profile showing me exactly how the colors will be. But I'm still on RGB. I can still use all my editing functionalities in RGB with the soft proof of how the DeviceLink will render my image later on. And this is the real rendered CMYK. So this is all in CMYK now. So I have a very nice feature to preview my work on the RGB, and I can still work on my RGB. So that's the part on RGB to CMYK. Very helpful for high-end photographers, for retouchers of images, to use the DeviceLink profiles for better RGB to CMYK separations. The next thing we will be looking on is tag reduction and safe ink. We'll look at this image. And that's basically as well one of the CMYK, that CMYK test image we are supplying with CoPra. When I'm opening this image here, I have assigned the swap-coated version 5 profile, so the grade 5 paper type to this image. That's my original. And if we are looking into this a little bit closer, what we see here, for example, here in this area, this is where I have a tag of nearly 400%. So assuming I should print that image on swap, I will have a problem because it has too much tag and total area coverage. So basically, I want to reduce the amount of ink on that image to be printed correctly on swap. And to do that, you can use as well the ICC functionality. For example, you would go here, convert to profile. You will go from a swap profile to another swap profile that I have created with CoPra already, which uses the max GCR settings for safe ink, basically. So I could use a normal ICC profile as well for this task for safe ink. But you'll see that this is not a good idea, and I will show that to you. So basically, if I do this conversion and I will look here into this area again, you will see that my goal to reach the 270 to 280, basically, my tag goal was to reach 280% maximum, is reached. And my image has not changed. So that's my original one. Have a look here in the gray background. This is only using black. It's only using 35% black, not CMYK. Well, that's my original, which is selected, and this is the ICC conversion. This is basically using 280%, and this gray background here uses now this percentage. And if I'm looking here into the magenta area, it uses 69% magenta and a little bit of K in there. And my black gradient here on top, which was produced only with CMY and without black, is now produced with a lot of colors here as well, CMYK. So my original values are this one. My magenta should be 70. My gray background is 35, and this was 60, 60, 60. So using the ICC conversion, you'll see that my gray background is 4 colors, and my magenta is not pure anymore, and so on. So a not good targeted conversion. So that's not good to be printed. Using a tag DeviceLink profile. So I switch to the tag DeviceLink profile. So that's another image, which is now on top of this. I reach exactly my tag value, but you'll see as well that my gray is still gray, that my magenta is still magenta, and I don't lose the information on the CMY here. And we can see this much nicer when we look into the channels. So if I'm just showing the black channel of this file, if I'm using the ICC conversion, it would look like this. So I have a complete reseparation, and my black is changing. So that's not what I want. I want to keep this and only reduce the tag where needed. And that's what this tag reduction profile will do. So you see that was the original one, and that's the tag reduction profile. And it will only change black in those areas where it's absolutely necessary. In this area, or for example, in the hair of this lady. Why is that necessary? The sum here, the total area sum, you'll see that we have ink here, which is 340 or even more. So much higher than 280, which was my goal to reach for the swap grade 5 paper. If I'm using the tag profile, you'll see that I have nowhere an area which is higher than 280. So I have to have more black in this area to reach my goal. But as well, the image is not changing visually. Visually, there's no change, but the separation is completely different. The tag reduction profile is the better choice than the ICC conversion because all my other colors, like my gray background or my pure colors, are not changed at all. The next quality leap or step I can reach is by using safe ink profiles. And we have typically 3 settings that we suggest to use. For example, what we call the safe neutral setting. This is more a setting that you would use to stabilize the press. So we want to use more black and less CMY so that the printer has more control on the gray balance and that has better printing capabilities. And by using just the safe neutral setting, we will look into how to create those profiles with CoPra later on, you will save only 10%. So it's not a much that you can save. However, when we look into the channels, the separation is quite different compared to the original one. So if that is my original one, and that's the tag reduction, where only a little bit of change is done, the safe ink approach is going to add much more black in there. If I have a much stronger safe ink, like the safe strong setting, I save already 17% of ink. If I do that, it looks like this. So I'm using much more black and much less CMY. And if I use the safe maximum setting, I even save 24% of ink. That's a lot of ink. Whereas with the normal ICC profile, with all those artifacts it produces, it can only save 14% of ink. So very much less of ink saving that you can get there. But as well with a lot of problems and artifacts when printing. So you should never use normal ICC conversion for this purpose. Again, if we look into the original file and into the CMY, that's my CMY without black. The tag reduction will only change a little bit, so it will reduce the CMY and add the black. So that's still a very typical separation. The safe neutral already is more aggressive, so it uses much less CMY. Safe strong is even more aggressive, and safe max uses really the maximum that's possible to reduce. So the separation looks completely different. However, the color appearance is exactly the same. So between this safe max setting, where you save 24%, compared to my original file, if I switch between those two, there is no visual difference. So that's the beauty of the safe ink profile, this high quality in terms of accuracy, visual appearance, and accuracy as well in terms of the delta E's, if we calculate them. That's very, very great. And the most important thing, the visual appearance is the same. And how to create those profiles, I can show you in CoPra. And we are going to the safe ink profiling module here. And it's very easy. You basically define the printer profile that you want to create the safe ink profile for. In our example, it was the swap coated 5, so the grade 5 paper. And you go to customize. And inside the setting, you can start with one of our presets. And for example, that's a tag limit. That's basically a tag reduction profile. And as our goal was to start with to have a tag of 280, you simply go there and type in 280, and that's it. You don't have to change anything here. The next step would be to create those safe neutral DeviceLink profiles. And that's by going here. So you could start with a safe neutral for offset. So again, you would select that. You'll see that the ink saving black start, black width sliders have changed compared to the tag settings. So that's what it does basically. So we change the settings here. Or if you go to a safe strong, you'll see that we'll use a higher black width setting. Or if you go to the maximum setting here, then you'll see that all those sliders are put to the maximum, and you don't have to take care about the details. Whenever you want to use a certain setting, you can always go back to that setting, for example, the safe neutral, and then, for example, modify again the total area coverage that you want to reach, 280%, and then you could go and say, okay, I want to have a lower ink saving or stronger ink saving, or I want to have a higher amount of black width or a lower one. So you have all the possibilities there to start. For starters, it's very good to choose the standard method because it will allow you only to have the ink saving slider. With the advanced mode, you'll have more control. You can control the black start, the black width, and the black start, for example, is quite helpful for large format printing, because there again, you can save a lot of ink for those Butex, Newer, and so on, large format printers that use a lot of inks as well during printing. You can use save ink profiles for those devices too. As they are very often having very big dots, you don't want to have those big dots starting in the highlight areas. So you would put the black start to a light starting point. Or if you are printing skin tones, you don't want to have this so-called peppering effect in the skin tones. Therefore, you could use the exceptions to preserve the skin tones. Very nice functionality as well, especially for those use cases like large format printing or as well newspaper printing. Other customers might tell you they have specific corporate identity colors, and the Save Ink should never touch those. You want to make sure that your client is happy with his colors. You can simply define your custom exceptions. So, for example, you have a certain CI color, and you can simply put in the values of that CI color, and here we go. And this color would then not be changed anymore from the DeviceLink conversion. So you can keep this color exactly as the client wants, if that is a specific color that the client wants not to be touched from the Save Ink conversion. And here in this graph, we always show as well which kind of settings it has. For example, if you use the Preserve 0% black, we don't add black in this area, which is used from our tag setting. For example, if I switch back to the tag limit setting, you'll see that this is not used. Whereas if you use the more Save Ink, you want to save on ink, so your goal is to get more black and less CMY. There you want to use much black as well in areas where there was no black before. So that's about Save Ink profiling. And the last use case I would like to show you is about CMYK-to-CMYK, one CMYK to another CMYK repurposing. And for this example, I would like to explain a little bit what kind of conversion I want to do. We'll have a tool which comes with CoPra, which is the Profile Manager application. And that's basically what I would like to show you here. Or basically what we want to do is we have a file prepared for Greco, so high color gamut, big gamut, high saturated inks, white paper, and we want to print on an offset process with uncoated yellowish paper, which has a very, very small color space compared to our Greco color space. I will switch the Greco, coated Greco color space as well on top here. So you'll see the transparent color space is our Greco color space, which is much, much bigger than our smaller offset uncoated yellowish paper. And of course, during the color conversion, we need to do a lot of compression to put all the colors in there. But still, we can see here the yellows are quite close, the magentas are quite close to each other, and the cyanes as well. Obviously, we get higher density with the Greco, or here the magenta would be higher density with Greco, but we have nearly the same hue. So we want to make sure that we have a pure magenta, pure yellow, pure cyan in there, and no contamination. So that's very nice to spot in this tool, which is the DocBeast Profile Manager. To create the DeviceLink profile we want to do, we go here, and we basically select our Greco profile as our source color space, and I want to go to my custom yellowish paper. So that's this one. So I select my source profile and my target profile, and then I could either select one of the presets that we have. That's always a good choice to start with one of those presets. So we deliver very well-chosen presets. In our example here, we are going to have a print-to-print, either traditional or automatic exception. So we want to do offset to offset, basically. So it's a very typical print-to-print application. Or it might be that we want to have a tag reduction with same source and target profile setting. Or we want to go from offset to graver, or a large format printing, close match, or higher chroma, or digital printing, close match, or a certain process standard digital print conformity. So we'll have quite a lot of useful settings to start with that you could choose. And in our example, we simply take the automatic exception here, print-to-print automatic exception, and basically you could go here to next, and then give this DeviceLink profile a name, gray coded to my custom offset coded, give it a tag value, and off you go. And you would be ready by that. However, of course, we want to know a little bit more about how to create those DeviceLink profiles in details. So we go to the Customize option. One thing we want to look at is the black generation part. We start with that. And in the black generation part, we have the same settings as in a normal printer profile creation, UCR, GCR, MinK, MaxK, and such. So if I choose GCR, for example, here, I will have basically the same setting as with a normal printer profile. So no real advantage over a normal CMYK-to-CMYK conversion if I use that. If I use preserve separation or preserve black, then I have these advantages that I was talking about when I want to keep the black separation of my original one. So I want to preserve the separation, and I want to use the enhanced shadows and preserve 0% black option. This is an example here which we show to visualize how the conversion is done. For example, you switch this off, you'll see what happens here, or if you don't choose the enhanced shadows, don't put the black in there. So it really symbolizes how the conversion, or what kind of conversion it will do for you. We are looking at the preserve black option, and we are looking basically at the preserve separation, those two ones. So I've created DeviceLink profiles, and we will apply them in Photoshop and see what they are doing. The other thing which is important are the exceptions. Here again, using the automatic exceptions, this is this automatic mode that we had in the RGB to CMYK example as well. Obviously, for CMYK to CMYK, we have a completely different image here. And again, I will start from 0 to show you all the options which are important. This is a CMYK example. We're going from CMYK to CMYK, and we are looking at all the features here. So, for example, if I want to make sure that 100% black is not rendered into 4 colors, but stays as 100%, I switch this option on, and here it will show me where this color is in this example image. So there are 2 patches which have basically the same 100% black value. This would make sure that only 100% black is not touched and just kept as it is. Keeping the gray option, it will keep all my original blacks, but it would not render from CMYK to CMYK. It would not put this to 50% as in this example, but it would, of course, take the different dot gain of the target color space into account. So it would calculate the dot gain difference and optimizes the cyan and the black, and in this example, the black, and make it the best approach to get to that color. The same things you can do with 100% CMY, which is basically those edge values. So you want to make sure that 100% cyan is not changed during the color conversion and is 100% after conversion. So that is an option that you can have here. Other options that you might have is to keep the entire primary axis pure. So you want to have that cyans are pure cyans, magentas are pure magenta, yellow is pure magenta. So you have this option here. Obviously, if we talk about primaries, secondaries are the next option. And a secondary color is a combination, as we show here, 70% cyan, 40% magenta, just as an example. It's a secondary color. And this means after conversion, this color is consisting only out of cyan and magenta. It will not be 70-40, of course, because we are looking to reach the best color that matches 70-40 in my target color space, uncoded yellowish, and not gray color anymore. So we have to do a conversion, but it will consist only out of cyan magenta. And this will make sure that all my gradients, my smooth blends, are pure colored and are not muddy and are not converted and distorted after the conversion. So that's a very important functionality here. Other important functionalities are duplex colors, so combinations of a primary color plus black. The same thing applies here. We want to make sure that the conversion, as in this example using cyan and black, is using only cyan and black afterwards, after the conversion, but getting the best color, colorimetric result compared to the original one too. And if we can do this for duplex, then of course we can do it for triplex as well, meaning that we have two combinations of colors plus black, and we want to keep this kind of color combination as well inside the triplex option. And here again, the automatic mode is a very mighty functionality that calculates all the best exceptions that you should use to get your work done. And switching to the custom mode always allows you to say, okay, I don't want that, or I want a certain option not, but this one. So you can override the settings that the automatic mode once gives you. So that's very helpful. But the automatic mode is a very good starting point. And again, if you're going here and saying, okay, I want to create that profile, I don't create the preview profile here, but the profile report, you can save that profile. As I'm using a demo license, for example, if you want to test the application yourself, you would get a demo license, and I would like to show you what happens with a demo license. That's the reason why I have this loaded here. So it will create a demo profile, which will only be used, can only be used inside the CoPra application, so you can't use it somewhere else. But for testing, that's completely sufficient, and it will create that profile for you. And during it calculates the profile, you could create another profile with a different setting. Now it has created the report already. And that report is, again, very helpful to analyze the profile quality. So here we can see the gray balance of my original gray coal and how it is converted to my uncoated yellow. And it gives me as well some information about the black point. Obviously, my uncoated has a much lower black point, which we have seen in the gamut view. So we don't have this high lab value, this very dark lab value. And we see as well how pure colors, for example, a pure cyan, pure magenta, pure yellow is not contaminated. Or even as well, my black is not contaminated. It's a pure color in here. So I have this information all at my hand as well, how a red, green, and blue is rendered. So I don't have to go inside Photoshop and check if my DeviceLink is doing a good job. I have it right into my report here. So that's very, very helpful to analyze the profile. And I can see right away the profile does a good job. There is nothing wrong. To prove that, I would like to go to Photoshop. So that's my original image. That's my image, which is in the Greco color space. And again, that's basically the test image that we supply with CoPra. And if we look in here, we see the gray background, which is only using black. And we see as well, for example, this guy here has a very neutral gray background, which is using here LAB00, so it's a neutral gray. So that's my original image, and I want to convert that to my custom yellowish paper. So that's the result of my normal ICC conversion. And if I look here into the gray background, you'll see my color is my gray is now 4-color, which is not nice. If I look into here, this yellow, for example, my yellow has a contamination of a little bit of cyan and magenta in there. This will produce those overprint issues we had in our presentation. Or 100% black, which is this anchor point number 3 here, which is rendered to 4 colors at the end. Not very nice. If I look into the separation, so that's my conversion that I've done with a normal ICC conversion using a good quality CoPra profile. So I created that profile with CoPra. So that's all nice. If we look into a competing product, for example, you'll see bad artifacts happening here. So the quality can vary already by using normal ICC profiles or using the CoPra profiles. The CoPra profiles give a much smoother rendering. However, the issues that we'll have with normal ICC conversions are still the same, even with CoPra profiles, and only DeviceLink profiles will be a cure for that. For example, using a DeviceLink with the preserve black option. If I do that, I'll have exactly my black channel from my original. If I switch back to my original here, so that's my Greco, that's the black channel of my Greco image, and after conversion, you'll see only the dot gain difference. So this is a little bit lighter, but we keep the original black composition as it is, and that's preserving the black channel. However, when we are doing this kind of things on a very high saturated big gamut like Greco to a small color space, this is not the best choice. You will see why. Therefore, we will use the preserve separation, which is the better choice, which still has a little bit of impact to all those areas where it's absolutely necessary, but gives us more contrast and more details. And I can show you this when we look a little bit more closer to this lady here, and especially to the hair of the lady. If that is my normal ICC conversion, if you look here, so there's a lot of details and definitions. So the normal ICC conversion using perceptual rendering intent gives you all the details that you need. If you use just the preserve black option, you will see what happens. You'll lose a lot of contrast. So it's getting lighter. So you don't have that detail anymore. Whereas if you use the preserve separation option, you will have that contrast. So if you switch between preserve separation and ICC, you don't see a big difference. Even the colors are a little bit cleaner, so it's nicer. The separation is nicer. So that's another advantage, basically, of the DeviceLink. Mostly the separations are much cleaner and nicer than the normal conversion, but you don't lose the separation, the details in the separation anymore. So the preserve separation is basically the option to choose. I've used the DeviceLink with a perceptual rendering intent. You can get even better quality. If I use the standard compression method inside CoPra, you'll see that we have higher contrasts, much better reds and greens compared to the perceptual rendering. So that's very, very nice. That gives already better quality. And if you look here in the background here, the gray background, this is still using only black. No contamination of other colors are in there. The yellows are pure yellows, no contamination in there, so that's all fine. My 100% black is 100% black, so I don't change this color, so I get much better quality for printing. The other thing I want to look at is in this guy here, because when we look here into this anchor point, this is number 2, so we'll see 0.4, which means we have a little bit of a yellowish tint, obviously because we are printing on a very yellowish paper. We see this much better if we go to the soft proof setting. So we go there, and we are selecting our document profile, which is this custom offset coated yellowish paper, and we want to simulate the paper color. And that's basically what we want to see. This is the real color view of how this print will look like. So it's a little bit of desaturated. The contrast is low because of this very, very small color space. And we see as well, the background is not neutral anymore. It has this paper tint compared again to my original one. So this is my original one, which has this 0.0 neutral background. So if I switch back here, and now I have the other option inside CoPra to choose a rendering option, which we call the absolute compression mode, which will make sure that despite the situation that we are printing on a yellowish paper, I have a neutral background, for example, from this gray background here of this guy. And we can see this here. 0.0, so we have, compared to the original one, neutralized this gray. Obviously, we can't change the paper white. The paper white is yellow, so we are going to print on that paper. But if we put this print side by side to my Greco original one, the gray balance will be much, much closer and much, much more faithful reproduction to my original. And this is one thing I've not shown you in my demo before, so I go back to the setting here. So we looked into black generation. So that's basically the preserve separation option and the preserve black option. And my suggestion was to use the preserve separation and the enhance shadow and preserve 0% black option. We looked at the exceptions. The exceptions we wanted to have are the ones from the automatic mode in this example. So using triplex, duplex, the primaries and secondary colors. And the rendering, it has all the normal ICC conversions options, rendering options, like perceptual, relative, saturation, absolute colorimetric, but it has as well additional rendering intents, and that are our ColorLogic rendering options. And a few of them are very that you have seen already in the printer profiling part, like standard compression, blackpoint compensation, absolute compression. And we have an additional one which is called dynamic here, but we have 4 additional rendering intents. So either you create DeviceLink that using the perceptual rendering intent, that's what I've done in my example, my first example, or you use one with additional rendering intents, which are standard compression or absolute compression. And you can either use standard compression and use this merge slider, for example, or you choose the absolute compression. And between those, these are the 2 differences that I had in my presentation with this image: standard compression and absolute compression. And that's basically what I've used. I've used the perceptual rendering intent in one of the examples. I've used the standard compression in the other one, and the final one was the absolute compression here. And if I switch back to Photoshop, this is shown here. That's the DeviceLink with the absolute compression using the preserve separation. That's the one using the DeviceLink with the standard compression, and that's the one with the perceptual with the preserve separation. So that's all what we can see here in this example, and that's quite good overview of how you can work with CoPra to create ICC profiles, DeviceLink profiles in a very high quality, leaving all the quality aspects intact, and don't destroy black, don't destroy separations, keep pure colors in a very high quality. So that's my presentation. I would like to thank you a lot